Hi everybody, today we're going to be talking about the object type inside of C#. So it looks like every single object that's created, and when I talk about object it's sort of synonymous with class. Class is a type of object, but pretty much every class sort of inherits or comes from an object, which is just a name for any class whatsoever. And you can actually, we were talking about upcasting a couple episodes ago, and you can upcast from any single class no matter what to the object type and it'll work. So we're going to create a public static stack. Stack is a data structure, and that's just a good example of how the object type works. And instead of static, I meant to put class, and we don't need these parentheses. So we're going to create a new int, and this is going to be our stack index. And we're going to create a new object array. It's called data. It's going to be equal to a new object, and this array is going to be able to hold 10 objects. So we could pass in any sort of class, and C# will accept it because object is the base class of any sort of class. And so in typical fashion, a stack has a push function, which takes in an object. We'll just say obj. And it's going to be equal to data at the stack index. I'm going to say plus plus, and we'll set it equal to object. So pushing in stack terms is just adding something to the array, and so it goes in at stack index, and then we increment it after we add it in at the stack index. And then there's also another function called pop, which will return an object. So for pop, we're going to return the data at the stack index. But since stack index will be 1 over what we want to put in, we're going to decrement it before we retrieve it. So we'll retrieve the last item in the stack index. So we can see this in action because if we create a stack, and then we'll just call this a stack equals a new stack. If we do this and then we say stack.push, we can push a string. And then I think since we're using object, we can also push an int, show object, and then push a double as well, you know? Like, we can really use any sort of type in here because we're using this object class. So it's basically just a wildcard and allows us to have some flexibility with our stack. So if we were to go back here and then say we wanted to assign the double equal to the stack.pop, right? This will return the last thing that we put in, which is this double. So we're getting an error that says it cannot implicitly convert type object to double, and object is a reference type, and the native types like int and doubles, basically any numeric types, are value types. So we have to actually explicitly convert this back into a double. But if we were to sort of do the same thing again, we'll say that this int is equal to stack.pop, and then we'll say, I think we can do this, where we do a string and set this equal to stack.pop. I believe that we will not, actually we do have to implicitly convert it to. So string is also a value type, I guess? Oh, no. So string isn't a value type, it's a reference type, but the reason that we have to cast it is because we're doing downcasting again. So I made a video on downcasting a couple of videos ago, and basically it's taking a higher class, basically the base class, which is object, and then converting it down. So that can cause some problems, so you have to convert it when you're converting to another object. So when you're actually converting a reference type, which is in this case object, to a value type, which is the numeric types like this is called boxing and unboxing. So I'll just have a little bit of code here just to show. So if we create a new int j, set this equal to 15, and then we create a new object of j equals j, we don't have to do anything. So this is called boxing it. It's taking this value type to a reference type. But if we were to convert this back into an int, we will get an error, and this is due to it not being able to implicitly convert, which we saw up here. So we have to implicitly convert, and this is called unboxing. So this is unboxing, and this is boxing. So one last thing I want to show is how we can actually override the ToString function. So every single object or type in C# has a ToString. So this will throw an error because we have an int here. But if I did .ToString, obviously we can do it, and then throws an error. But if we were to say string j, otherwise. So every function has that, and for some classes we'll want to actually override that. Stack may not be the best example, but basically if you do not define a ToString for a class, it will return the type name, which this case would probably work out just fine. But if we wanted to set an actual stack name, right, let's just say that, then we can go ahead down here. And since we're inheriting from the object type, we can say public override string ToString, and you can see immediately it just gives us some boilerplate code. So we're inheriting from base, which is object. You can see class system.object down there, .ToString. So we're going to actually want to return stack name, which is pretty cool. So I'm going to actually have two different lines here. I'm going to copy this, go back to what we were having, comment this out for now. I just want to show the difference of what it's going to give us. So if we did right line for what stack .ToString will return, and then we'll do a read key so that we can see the results. So it returns stack, which is the name of our class down here. I'm going to set stack name equal to custom stack, and then comment out this line of code, and then return this. Go ahead and start this again, and you can see that we're actually now returning our custom ToString, which is custom stack. That's pretty cool. And that is it for the object type in C#. Thanks for watching.